Warm greetings to all. Myself, Mrs. Pranali Pradeep Hatode, a research scholar of Thadomal Shahani Engineering College and an assistant professor in KJ Somaya Institute of Technology, Mumbai. My topic of presentation is OCTA image classification and analysis of diabetic retinopathy using WGAN augmentation. Now, all of us know that deep learning has exhibited very good result for the large data sets. But when the data set is limited, its performance gets little bit lower. For this, we need augmentation technique. Specifically, when it comes to the medical images, many a times, many diseased images are very less in quantity. We do not find them easily. In this case, we need to augment the data. We need to create synthetic data out of the original images to process them over a deep learning model. So this research basically focuses on augmentation of medical images, the better augmentation techniques, and how the images are classified using which deep learning model and their prediction. Now, basically, in this research work, the analysis of the OCTA images on diabetic retinopathy is done. Diabetic retinopathy, all of us know that it possesses a significant risk of vision loss and life-alerting complications, including kidney and cardiovascular diseases. There are primarily two types of diabetic retinopathy, that is NPDR, that is non-proliferative diabetic retinopathy, which is the early stage of diabetes, and PDR, that is proliferative diabetic retinopathy, which is the advanced stage of diabetes. Now, during its journey from non-proliferative to proliferative, it goes through various stages, that is mild, moderate, and severe NPDR. This research focuses on the categorization of images into all five categories of the diseases. In this research work, as I said, the images obtained were less. So the main requirement for the research was to augment the data. Since it is a medical image, more accurate, more perfect results are expected. So for that, the augmented data also must be more realistic than any other, just like the real data. So for that, various augmentation techniques were tried. After that, I came to a conclusion that WGAN was the best augmentation technique over the conventional augmentation technique of enhancing the data by rotating, flipping, clipping, etc. Now, what actually WGAN does, that we will discuss later. But first, let us understand the methodology of my research work. Here in this research work, I have obtained around 800 OCTA images from IEEE data portal. Then these images were WGAN augmented into 19 instances. Now these instances are nothing but the HDF files. HDF are hierarchical data format files, okay? And these are further converted into PNG images by PNG image generator model, and then eventually they are given to the ResNet 50 model for classification and prediction. Now coming back to WGAN. Now WGAN is a variant of a generative adversarial network, that is GAN. This is Wasserstein GAN. It is also its acronym is WGAN. It is a particular kind of GAN. The goal of WGAN is to get around some of the drawbacks of conventional GAN, especially training stability and mode collapse. It achieves this by calculating the difference between two probability distribution using Earth movers distance. So let us understand what actually or how WGAN architecture is built. Basically, WGAN architecture is built with two blocks. One is generator and another is a critic model. Both of them constitutes the convolutional neural networks in it. Generator adds some random noise and creates the fake image based on the real images which is given to the critic. Critic goes on calculating the loss function of the fake image on basis of the real image database which it has. This loss function is given as a feedback to the generator. Based on the value of the loss function, more the loss function, that means more accuracy is needed to the fake image. The generator goes on adding the realistic elements to the fake image, and in this way, more and more realistic synthetic data is being generated out of WGAN augmentation. All this data is very large in size, and it is really very difficult to download this data to the machine because it will be a heavy load to the memory. Therefore, it is stored in HDF format, that is hierarchical data format, or .h5 format. Basically, it is a format in which the weights of the augmented data are stored in form of the arrays. Now, this data or this .h5 file is downloaded from the WGAN working model, and then it is given to the PNG image generator. Now, in my research work, first I will discuss the workflow of PNG image generator. Here, the .h file obtained from WGAN is uploaded to the image generator. Then it is given to, then a directory is created to store the generated images. The PNG image generator model is loaded. Then it is called, and 500 images are created by the PNG image generator out of each and every instance of the .h5 file. Then entire data set is zipped and downloaded. Now, why PNG format is chosen? Because from the study, from the research and study, I came to know that ResNet 50 works best on PNG image format. .keras file is downloaded from this PNG image generator, and then it is given to the predictor file, to the predictor model, to the classification model. That is a ResNet 50 model. In this research work, I have used a pre-trained ResNet 50 base model. Later, I optimized this model according to the complexity of my data and the accuracy which I required. First, let us discuss how the workflow of the ResNet 50 classification model is. Now, the PNG images from PNG image generator are uploaded to the ResNet 50 model. Batch size is decided. Then the data is divided into training and validation size. That is 80% is used for training and 20% is used for validation. Then the model is defined. After that, various learning rate schedulers were used. Then after that, to get better accuracy, I tried to freeze the 150 layers of the model and later compiled it to get the accuracy. Many other variations were made into that I will discuss in the result when I discuss the results. Then the .keras file from the classification model is given to the prediction file or the prediction model. The prediction model again is a ResNet 50 model. Here, The Keras file from the classification model is uploaded. The size is defined, okay, and later the array is adjusted and prediction of the classes, any random images is done using this model. Now to discuss about the results I got at every stage of my research. First, I started with three-layered or customized three-layered CNN model with the 100 images that I received from one of the author. Without augmenting this data set, on 30 epochs, I received 43.44% of accuracy. Then on the same model, I analyzed these 800 images, which I received from IEEE data portal. I augmented those images with the simple augmentation technique. On 30 epochs, I got 48.97% of accuracy. To improve this accuracy, I thought of increasing the layer of the CNN model, and therefore I increased the layer to 5. I augmented these 800 images by using GAN augmentation. The images I got were 12,500 with 150 epochs. But surprisingly, the accuracy fell down to 20%. Later, the same model I used for more number of images, that is 47,500 images generated by GAN, and it improved the result, that was 37.57%. Later, I went for WGAN augmentation. I generated 47,500 images. On 150 epochs, I got 40.30% of accuracy. Initially, we think that going on increasing the layers of the CNN will help, but that doesn't actually happen because loss of gradient take place when we go on increasing the layer. So for that, to avoid this, I chose ResNet 50 for that, because ResNet 50 is capable of overcoming this disadvantage of gradient loss because it is having the skip connection in it. In skip connection, we are able to use all the weights of the model without losing the gradients. So ResNet 50 was operated on GAN generated images, and it gave me 62.48% of accuracy. Later, to increase my accuracy, I started fine-tuning and optimizing the base model of ResNet 50. In this optimization, initially, I froze all the 150 layers and I fine-tuned the learning rates for various values. Then the accuracy which I achieved, that was 99.95%. But the drawback of this accuracy was there was a lot of instability in the exponential curve of the accuracy that I received, which would definitely affect the prediction of the disease. So to improve that, what I did that I unfroze all the layers of ResNet 50. Then I I removed the computational head of the model. I inserted my own computational head. I started fine-tuning the last 20 layers of the model. And the accuracy that I received was very good. That was 100%. But the curve that I received was too accurate to be accurate. That is, it was 100% right from the first epoch. Whereas this is not expected. The expected accuracy is that there should be an exponential rise in the accuracy curve. So for that, I started changing the learning rate values as well as the dropout layers values and so on. After doing all these changes, I received a very good accuracy with a better exponential rise in the accuracy curve. This lead to the better prediction of the data. The Keras file that I received at this accuracy value was very good, which was fed to the prediction model, and accurate prediction for the random images given to the model was done, and this was verified by the ophthalmologist. Now, to conclude this, we can say that WGAN gives the best augmentation synthetic data for the prediction of the disease like diabetic retinopathy, where the disease elements are very minute. That means the data or the images are very complex. So it can give more realistic images as compared to any other augmentation technique with the stable accuracy too. Then PNG image generator gives better result with ResNet 50. ResNet 50 is good for such kind of complicated data. Only the thing is that to reach to your expectation levels of accuracy, we must fine tune it or optimize the model according to our requirements or the requirement of data complexity. While doing this, I have gone through the change in various hyperparameter tuning, like freezing, unfreezing of the layer, fine tuning of the learning rate, optimization layers, and the dropout layers. Throughout this work, I have gone for ADAM optimizer because SGD optimizer doesn't work good for my particular work. So this is how I conclude that WGAN augmented OCTA images for diabetic retinopathy detection is a better choice as compared to any other augmentation and classification technique. So thank you all for hearing this presentation. Thank you once again.